Hello, it's time to play Pips. Let's play some dominoes. Looks like we've got 3 Rodolfo puzzles today. We'll start with easy. And let's see our dominoes. All right, so we need 10. Oh, and 12. We need 2 sixes for that, and a 2 pointing into something, which has to be this, actually. So now we need the 2 to have the other 1, so that forces the position of that. We now need 2 2s. So it looks like we can make the 10 out of 2 5s, a 0 into the 6, and then a 6 into the 4, and I think that'll be it. It is. Okay, great. Let's move on to medium. Okay, so 11s, as we know, always require 1 5 and 1 6. So that means we have 2 5s and 2 6s already accounted for, and then we'll also need to make a 10. Okay, so the 10 will be 6 4 because we've already used both the 5s that we need. That's good to know. We also need a 2 in the 2 region, obviously. That's the only thing we can do with it. So the 2 will be pointing into the 10, so now the 10 will have a 6 up there. Also useful to know. Oh, and greater than 4 in the single cell is valuable because we know we're a bit constrained on 5s and 6s. We've already earmarked, we've sort of put aside our 2 5s. So that'll need to be a 6 up there. So we have 1, 2, 3. We now have 6 4s spoken for, which is all of our 6s. So we can't use any 6s, kind of just out in the void cells down there. That's just something to keep in mind, I guess. 4s look like they're not useful because they can go neither in the greater than 4 nor the less than 4 three-sized region. So maybe we waste a 4 just to stick up into those. Both of our 4s, maybe we do. I don't know. They might be able to go the other way as well, but this is a plausible outcome, I think. Right. What else? Oh, the 6 needs to be connected to something small. That I could have put in a while ago. That needs to go there. So now we need another 6 going into the less than 4. Oh, have I broken it? I think I might have done. Less than 4. Yeah, what have I done here? Oh, I see. Sorry. It's because, yes, this was just a temporary placeholder thing. But in fact, those have to go the other way around. Because that allows us to connect a 5 to a smaller digit. There we go. Sorry about that. And then we have the 6, 6, which indeed does put a 6 in the greater than 4. And our last useless 4 goes in the void. So yes, the 4s were in the void today. All right, we'll try the hard puzzle. Let's see how this one goes. Okay. We have some 0. Oh, look how many zeros we have. We have 5. We need at least 5 zeros scattered around. And we have exactly 5 zeros. That's useful. That's good to know, I think. Is that correct? 1, 2, 3, 4. Yes, we have 5 zeros. That is helpful. We also have a 12, which as we know is 2 6s connected to, once again, to a greater than 4. So we do need a 6 pointing to a 0. That's 100% confirmed. So that definitely goes there. Then we need a 2 connecting to something that goes into an 8. Is that at all constrained? 2, 4, 2, 3. Those are our only options. So that means the 8 is a 4 or a 5 connected to something greater than 4. We have a 4, 6, 5, 6. So I think that means we're always going to have a 6 in the greater than 4. Is that right? Sorry, so the 2 is a 3 or a 4, which means the other side of the 8 is a 4 or a 5. Yeah, I think that's right. Okay, so that's a 6 spoken for, I guess, and another 6 in the 12. So that's 2 more 6s spoken for. We have 1 more 6 to play with, which could go in the 10. Oh, I haven't noticed this enormous equivalence region. 7. I think 7 might be the largest possible equivalence region, or could we do 8? Anyway, I'm not sure. So what do we have 7? Ones? It might have to be ones, I think. Am I certain of that? I'm not yet certain of it. No. I think I'm increasingly certain of it. I think it might have to be ones in there. That's useful. All right, so the 3 connects to an 8. Then the other half of the 8 is something that is itself connected to a 1. So what are our 3 options? It couldn't be 3, 1, because then we'd need 7 to finish the 8, which we can't do. So it could, and it can't be 0 for an even more extreme region. So I think it has to be 3, 2, which means we need a 6 that connects to a 1, which we had in the last puzzle as well. So that goes there. Okay. Do we have anything that can make an 8 in one domino? I suspect we don't, which means we'd have to cross into the 0. Doesn't look like we do. Okay, so there's a vertical, there's a 0 that goes into the 8, and then the 8 that connects to a 1. So, for instance, if we put a 0, 4 here, we'd need 4, 1. Do we have that? We do actually have that. Okay, are there other possibilities? We have 0, 5 connecting to a 3, 1. We do have that as well. Okay, so there are at least 2 options there. I can't assume that at the moment. We have the same thing, though, here with the 0, 6. All right, we have lots of these. Okay, so the 0 points into something, and then we would need that other half of the 6 to point to a 1. So this would go here. Then we'd need a 2, 1, which we don't have. So I don't think that's possible. We could put a 0, 5, in which case we'd need a double 1, which we do have. Actually, how many 1s do we have? 1, 2, 3... 4, 5, 6, 7. Oh, right. Okay. So I don't think we can do this because I think we need all of our 1s. Yeah, that makes sense because there can only be 7 possibilities for each. There are only 7 pairing possibilities for each domino half. There's 1 through 6 plus 0. So that's 7 possibilities to be on the other end of a 1. So we will need all of our 1s in there. So this is also not possible. So 0, 1 is also not possible. So I think it might have to be 0, 3, and then 3, 1. Okay, and then I think the double 1 needs to go here to maintain geometry up at the top of the grid, which means we need a 1 pointing down into the 10, and possibly another 1 pointing out into the 10, but also could be going to the side. Actually, I bet it'll be this. I bet it'll be this 0, 1 here, because we couldn't put 0, 1. We need the 1s everywhere, which means the 0 needs to connect to something. Oh, no, sorry. It could go up there as well. No, it couldn't because we already said we don't have a single cell 8. Okay, so I think that does mean it goes here. And then we need a 1 pointing down into the 10, which could be a 4 or a 5. So the other half would be 4 or 5. Either one of those would work in terms of going into the 0. We also need a 6 connected to the greater than 4, and now we only have one possibility for that. It's a 5. So, we're getting close here. What about this 8 situation? 4 and then 4, 1, we still have that. And then 5, we would need a 3, 1, which we no longer have. So this is not possible. So the 0 into the 8 will be a 0, 4, and then we finish this with a 4, 1 that way. Great. Okay, we're getting very close. So now we only have 1, 1 left, which goes here. So now the 10 is finished off with a 5 that goes into the 0 region. I hope this doesn't break suddenly. No, it won't. It's correct. Okay, so the 2 goes into the 8, and we finish the 8 with another 4, and the 6, which is greater than 4, and there we go. That was it. Oh, and it's a person. I didn't realize that the grid is in the shape of a sort of stick figure. Okay, I guess it's not a stick figure, but a very sort of simple illustration of a human. All right, well, those were the pips. I always enjoy those Rodolfo puzzles that they solve very cleanly. All right, back tomorrow. Bye for now.